How many 4-symbol radio call signals are there that use either all letters or one letter followed by 3 digits? Now for this problem here, it's very tempting to say the first letter must be a K or W, so let's put a 2 there. And to think about it and say, well, I have 26 letters, I have 10 digits, and to write 36, 36, 36. A lot of students will write that as the answer for part A. But you should realize this. The 2, 36, 36, 36 says my first one can be a K or W. 36 choices means I can pick any letter or any digit. Pick a 3. The next 36 says any letter or any digit. And the last one. So 2 times 36, 36, 36 allows codes of the form of K3BJ. Well, that's not either one of the forms, all letters or one letter followed by 3 digits. So this technique is not good. You can't combine this all into one quick answer. Notice we have 2 different types of codes or call signals that we're looking at. In other words, all letters and one letter and 3 digits. Because this is 2 different types of call signals, we have to break this up into 2 different piles. So for part A, first must be a K or W, so there are 2 choices for the first one. And then 26 times 26 times 26, because we can have repeats without, since I didn't mention anything. Plus, now for a letter and 3 digits. Well, K or W, digits, no restrictions on the digits, so it's 10 times 10 times 10. So the answer for part A is both these pieces and then add them together. Part B says the first letter must be a K or W and no digit is repeated. Now it didn't say anything about letters, so letters can be repeated. It just said that no digit can be repeated, so we adjust our second pile as 2 times 10 times 9 times 8. Part C says the first digit must be a K or W and no letter or digit may be repeated. Well, K or W, now we're not allowing repeats on letters, so one letter's been used. 25, 24, 23. Now remember, these are 2 separate piles. So what letter I picked in the first pile can still be used for the first letter in the second pile. So 2 choices there. 10 times 9 times 8. 5 people, 3 guys and 2 women, are asked to write down an integer between 1 and 15 inclusive. In other words, pick a number from 1 to 15, integer. How many ways can they pick the number if everybody picks a different number? Well, part A. Everybody picks a different number, so we have 15 choices for the first number, 14 choices for the second person from the number they picked, and 13 times 12 and then times 11. Part B. The guys pick the same number and the women pick numbers different from the guys and different from each other. So we can group this as here's our guys and here's the women. Now we can think of the guys, instead of having 3 separate blanks, we could put it all in one blank, because all of them have to have the same number, which means 15 choices. But if you put 3 blanks here, the first guy had 15 choices. Whatever he picked, the other 2 have to pick the same one, so they both have 1 choice. Now the women have to pick numbers different from each other and different from the guys. So the first woman has 14 choices, and the next one has 13. Part C, exactly 2 of the people pick an even number. Well, let's let the first 2 people have even numbers. Now, nothing was said about these even numbers having to be the same. They could both pick 8s, they could pick an 8 and a 12, but they have to pick even numbers. So first of all, we have to figure out, from the integers from 1 to 15, how many even numbers are there? Well, you have 2, 4, 6, 8, 10, 12, and 14. So looking at those, we know there are 7 even, and if you count it at the odds, there's going to be 8 odd. So if we're going to make the first 2 people here pick even, there's 7 choices there and 7 choices there, and the other 3 people have to pick odds because it says exactly 2, so the last 3 people have 8 choices. Now in this example, I've made the first 2 pick even. I could have made the first person and the third person, first person and the fourth person, first person and the fifth person. So in other words, where these arrows are pointing up, those are the 2 people that are going to pick the even numbers. I could have also had the second person and the third person pick even. So I have to look at this and figure out all the different ways that 2 of those people, in other words, which 2 people could pick even numbers. With what we know right now, the easiest way of doing this is drawing these little arrows. When we get to section 6.4, we'll have another way of finding this, which will make life a little easier. So if I look through here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different ways that 2 of those people could have been selected to be the even choices. So I need to take that answer here, the 7 times 7 times 8 times 8 times 8, multiply it by 10. Bill and Sue and 5 of their friends go to the movies. They all sit next to each other in the same row. How many ways can this be done? Well, first of all, Bill and Sue and 5 friends means that there are a total of 7 people. Unless otherwise mentioned, assume that there's only 7 seats, so those are 7 seats. Part A, Sue and Bill must sit next to each other. So we're going to put Sue and Bill in those 2 spots. Now, we could have Sue in the first seat, then Bill, or vice versa. So there's 2 choices for the first seat, and then 1 choice for the next one. Now, the other 5 friends, we don't have restrictions on them. But remember, once somebody's in a seat, they can't be in any other seat, so there's no replacements, no repeats. So there are 5 choices here, 4, 3, 2, and then 1. Now in this problem, I put Bill and Sue into the first 2 seats. We could have placed them into the second and third seat, third and fourth, fourth and fifth, fifth and sixth, or sixth and seventh. So if you look at this, 1, 2, 3, 4, 5, 6, we need to take this answer here and multiply by 6 in order to move Bill and Sue across the row and at the same time being next to each other. We could have also written this as 2 factorial 5 factorial times 6. Part B, Sue must sit in the middle seat. 1, 2, 3. So there are 7 seats. We're told Sue has to sit here. So there's 1 choice for that seat. Now in this problem, part B, there is no restrictions on anybody else. So we have a total of 7 people. 1 person's already seated. So there's 6 choices. 5, 4, 3, 2, and then 1. Or in other words, 6 factorial. Part C, Sue must not sit next to Bill. So in this example, we want Bill and Sue to have at least one seat between them. So it's sort of like Part A, except now instead of them being next to each other, they can be apart. So we put one of them in the first seat and the other one in the third seat. Now the other people have no restrictions, so they can be in any seat. So 5, 4, 3, 2, 1. Now just like in problem 16 part C, I need to draw the spots where Bill and Sue are being seated. They can be in the first and the fourth, or the first and the fifth, first and sixth, or first and the seventh. So that's one in the first seat and all the way through. We could have also had one in the second seat, and we continue this pattern all the way through. Sometimes it's a little easier to redraw the blanks each time you move people over. But if you count through this, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I need to take this answer and multiply by 15 in order to move everybody through the row. Now if you think about this, there is another way of doing part C. Part C says we don't want them to sit next to each other. Sue must not sit next to Bill. Well, what's the opposite of that? If you think about it, all the different ways you can place them in the row, Sue and Bill can either be next to each other or they cannot be next to each other. So if we look at the idea of total minus what we don't want, well, total is place all 7 people in the row without any restrictions, and that's 7 factorial. So for part C, what conditions do we not want? Well, we don't want them next to each other. Well, how many ways can they be next to each other? Notice that's our answer for part A. So for this example here, depending on how you set the problem up, you can either solve it like that, or you can solve the problem, in that manner. Both of these methods will get you to the same answer. Part D. How many ways can they be placed in rows? Sue sits at one end of the row, Bill sits at the other end. So Sue sits at one end, Bill at the other end, so there's 2 choices there, 1 choice there. And no restrictions for the rest of the group that's in the middle. So 5 times 4 times 3 times 2 times 1. So we could have written it as 2 times 5 factorial. Part E, Sue, Bill, or Jan sit in the middle seat. In part F, which is very similar, we got to make sure we catch the difference. Sue, Bill, and Jan sit in the middle seats. Now part E says we're talking about the middle seat. In other words, that one spot. Part F says we want these 3 people to sit in those seats that are in essence in the middle. So in part E, Sue, Bill, or Jan sit in the middle seat, so there are 3 choices there. Now which one of those 3 is in the middle, the other 2 can be anywhere else. So 6 times 5 times 4 times 3 times 3 times 2 times 1. In part F, we want all 3 of these people to be in the middle of that row. So 3, 2, 1. Now, those 3 people are placed in a row. The rest of the group can be anywhere else. So 4 times 3 times 2 times 1. So you got to be careful about the last little bit. In other words, that middle seat or middle seats. They make a big difference. Also, the or and the and also keys in.